Okay, so I'm happy to have on stage Wier. He's currently working as a web developer in Uganda, and he will talk about last mile Django. A big round of applause, please.
Hello. Okay, so as Jacopo said, my name is Wier. I'm currently a senior software engineer at a company called Phoenix International, which sells pay-as-you-go solar power kits in Uganda. And before that, I worked at a small NGO that ran data collection projects literally all over the world, but focusing on areas where data collection is most difficult. So remote and rural areas, countries that are affected by conflict, and just the developing world in general. And that's what my talk today is about. So specifically, what are the challenges in writing software for the developing world that engineers from Europe or the US, such as myself, might not be as accustomed to? So there's three things that I'm going to talk about. If I can get the slides working. So the first is connectivity. So users in developing countries are less likely to have fast and reliable internet connections. The second is languages and literacy. So developing countries often have lower literacy rates, which makes local languages relatively more important. And reference data. So external sources of data are more likely to be unavailable or to have low quality. So starting with connectivity, users in developing countries aren't usually going to have the same quality internet access that you would expect in a major city in the developed world. And that's especially true if they're living in remote or rural areas, as is often the case. And that also means that they are much, much more likely to be using mobile internet primarily or even exclusively. So every time they access the internet, even if they're at home on their laptop or at their office working, that's going to be through a 3G or maybe a 4G mobile connection. And that means two things. So first, again, the speed is going to be much lower, and it's also going to be much more variable. So for example, the surrounding geography doesn't really affect your internet speed if you're using a wired connection, but it can with mobile because it's dependent on reception. And secondly, people are usually going to be paying per megabyte instead of per month. And comparatively, each megabyte is going to be much more expensive. And when you combine that with the fact that these are, in general, less wealthy places, so relative to the average income in that area, that disparity is going to be even more pronounced. And so the result of that is that when a user is accessing a site, they aren't necessarily just thinking about what that site can offer them, what they can get from it, but they're also thinking about how much in terms of data and therefore money it's going to cost them. So here's a map that I think illustrates this quite well. This is the most popular browser by country in 2015. Green is Chrome, red is Opera, yellow is UC Browser, and there's a couple other ones in there also. So obviously, Opera is hugely more popular in sub-Saharan Africa and not so much elsewhere. And the reason for that is how Opera handles mobile connections and the data that they send to mobile connections. So I'm not an expert in this. I don't really know all the details, but my understanding is when you make a request through Opera Mini, the response actually comes through Opera servers where they're doing some compression and processing, and the end result of that is lower data usage. Now again, because this is translated directly into the amount of money that someone is spending on accessing that site, that becomes a much more valuable feature for people in Africa than anything that Chrome, Firefox, IE, or anything else can offer. So to reach people in these areas, it's important to minimize how much data your application transfers to the clients, and in general, just to think about how your application handles slow connections. So that's obviously like a very big area and very much outside the scope of this talk. And there's also a great overview by Chris Adams yesterday in the context of friendly web development about reducing the amount of data that you're using. So I'm just going to add two very small observations, specifically about the relative advantages of rendering on the server versus a single-page application. So for more traditional server-side rendered application, most user interactions require a request and a response. They'll transfer sort of a medium amount of data back and forth. It's going to include some boilerplate that can't be cached, but most of the application logic doesn't have to be sent as templates or JavaScript that's stored in the server. So in a single-page application, it has a larger initial request because it's sending that JavaScript and those templates. Maybe. Is that better? Better? Okay. So a single-page application has a larger initial request and only smaller requests after that. So the choice between those two is very important for how your site handles slow connections and how much data it uses. But it's also not necessarily clear which one is better in all cases. It really depends on the usage pattern of your application and on the application itself. So the advantage of a single-page application, or one of the advantages, is that it does give you a lot more control over what's loaded when. So potentially your app can be much more responsive with slow connections by allowing some interaction without requiring anything else to be loaded or to having to do that request response cycle. So again, the trade-off is, of course, the larger initial request, and if your application is very complicated, that can be very large. And if users are generally accessing your site only once, it's probably not going to be worth it in terms of data usage. But single-page applications do have another advantage in that it makes having some limited offline support a lot easier. And when you're dealing with a connection that's not necessarily just slow, but it's unreliable, that's not always on, that's fading in and out, offline support can make a huge difference to user experience, even if it's very, very limited. And while that isn't impossible to do with a server-side rendered application, it's much, much more difficult because you don't have that control over which parts of the which parts of content are loaded into the browser at different times. Okay. Another thing that you can do to reduce data usage, which can be very powerful, although it is much more involved, is to have an optional low bandwidth version of your entire UI. So Gmail does this. You might have noticed if it takes too long to load up your Gmail, it'll prompt you to have the HTML only version. So you can do a similar type thing by having a version of UI that avoids large images or maybe even all images and uses just the basic JavaScript. So replacing fancy jQuery components with basic HTML inputs and various other things like that. So the next thing that I wanted to talk about is languages and literacy. So you're probably all very familiar already with internationalization in Django. What I'm talking about here is something a little bit different. So not just supporting 3 or 4 major languages, but supporting a larger number of local languages, which instead of having hundreds of millions of speakers, may only have a few million or even less. So why is this important? So on the top of this slide here is a linguistic map of New Guinea. And what's interesting about New Guinea is there are about 800 different languages in New Guinea. And although the official language is English, it's not widely spoken. So there's a trade language called Tok Pisin, which From the name, you might be able to guess is an English pigeon. But essentially, if people in New Guinea are going to use your application, it has to be translated into a local language because they're not going to be able to speak English. And even in less exotic locations, like Africa, where French, English, or Portuguese is largely spoken, or Central Asia, where Russia is largely spoken, it's still not necessarily optional to support local languages. Part of the reason for this is lower levels of literacy. So we do expect that people need to have some degree of literacy to access the internet. But when people are at that absolute minimum level, having to read in a second, third, or as sometimes is the case in Africa, a fourth language, that just adds an additional barrier to their understanding. And that's especially true if you're trying to communicate something technical, something unpleasant, or something generally difficult to understand. So a good example there is an error message. Usually there's going to be at least some technical information in there, and someone who is seeing that is probably already annoyed. They don't need to have to deal with understanding that in another language that they may not speak very well. So you might ask, what is the difference between supporting major languages and a lot of smaller local languages? So there are two additional challenges in my experience. So firstly, just as with any data, the more instances you encounter, the more likely you are to have bugs or scaling issues. So all the different issues and comparisons that Raphael brought up in his talk yesterday become more important. So as a real example, if you're supporting 20 or 30 languages, which is not unusually high for a sub-Saharan African country, and you're using a model which adds a column for each language, your tables are going to get very ugly very quickly. Which is not to suggest that that's necessarily the wrong solution. Other models may have their own problems which are more relevant to you, but it is an example of why you need to be thinking about having a lot of languages. And the other thing is that translations are going to be much more difficult for local languages. So if you are translating from English to Italian, you're probably not going to have any problems finding professional, technically skilled, and affordable translators. Now that's not necessarily going to be true if you're translating to Tajik or Lingala or one of the many New Guinean languages. And practically what that means is that you'll have to rely on less professional sources. So friends, people you know from partner organizations, if that's relevant, or even crowdsourcing. And the results of that is it dramatically lowers the average technical skill of your translators. And that means it's necessary to not just make your application able to be translated, but to make it easy to translate as well. So a lot of how to do that is just using the tools you're probably already using effectively. There's often a habit when doing internationalization to just type import underscore, import get text as underscore, go through your files, put an underscore in front of everything, and then from then on it's officially someone else's problem. But of course you need to pay attention to things like translation comments, pluralization, and context strings, which are going to make things a lot easier for your translators, especially if they're not as technically skilled or technically savvy, or they don't really understand the details of your application. And kind of a side note, although it is related, so it's my opinion, and I think a lot of other people's opinion also, that multilingual content in the database is always good practice, even if you only expect one language. So if you think about it, really every bit of text that's generated by a human has implicitly a language associated with it. The only choice is whether or not that metadata is stored and managed within your system or whether it's implicit. And there's a close analogy here with dates, times, and time zones. So you all know that a date implicitly has a time and a time zone associated with it. The only question is whether or not you are storing that time zone and that time. And if you've ever worked with a system that just stored raw dates without times and time zones, and eventually had to migrate that into a system that was time zone aware, you know how much of a pain it is. So it's very similar with languages. And the final area that I wanted to address is reference data. So most applications are going to be integrating data from other sources, at least a little bit. And in developing countries, this is much more likely to be unavailable or low quality. So the perfect example of this is addresses. In many parts of the world, addresses aren't really as widely used. So if you want to find someone, instead of looking for a street and a number, you go to their neighborhood or to their village, you find a landmark that they've told you about, and then from there you either ask around for someone that knows them or you call them. And also administrative zones may not be as well defined in developing countries. The hierarchy may be inconsistent, so different organizations may use different hierarchies of addresses and administrative zones. And also the zones themselves may not be well defined, they may be overlapping or just not widely used. So that doesn't make things very easy to encode digitally, but it's as important as ever to be able to find people. So being able to handle that kind of dirty data is especially important when working in developing countries. So as a real example of this, the address problem is something that my company dealt with a little while ago. So in Uganda is a country that does have many different address structures, and it sort of depends on who you talk to, what address structure they're using. So my organization was using region, district, sub-county, parish, and then finally village. So firstly, it's impossible, well not impossible, but extremely difficult to get a list of all villages and parishes. And then we also had a form where to get the choices for the smaller zones, so for the villages or parishes, you had to first input a higher zone, so a sub-county or a district. The issue there was that people often don't know their sub-county. They may not have a parish that's separate from their village, but at the same time, those two zones, the sub-county and the parish, can't just be ignored because the higher level one is the district, which is quite large, and there may be many villages with very similar names within that district. So the end result of this is we ended up with about 25% of our users living in other, which was quite a large problem because a major reason we might need to be finding someone is because they owed us money and therefore didn't really want to be found. So the solution to this was to allow people to look up higher level zones from lower level zones. So since sub-counties in Uganda are often named for the principal towns that they're near, this allowed people to find a sub-county from a village, and that reduced a lot of the issues that we were having. So another example related to addresses is spelling and transliteration mistakes. So on the slide there are a couple lists of alternate spellings for cities in Somalia. So those are actually the larger cities, just because that's what I could find. But this problem would be much more pronounced at the town or village level. And obviously, if you are at any point requiring an exact string match on one of these names for something to move forward, you're going to have a lot of problems. So a good solution to this type of issue, where you do have non-standard spellings, is one of my favorite algorithms, which is called the Levenstein distance, which is defined as the minimum number of inserts, deletions, or changes to get from one string to another. And it allows you to get a measure of the similarity between strings instead of a Boolean matches or doesn't. So you can combine that with the threshold for the maximum distance per characters to recognize many different spellings and map them into one standardized spelling, which is helpful in a lot of different situations. So to conclude, I'd just like to say a few things about motivation. So why should you care about these types of places in the first place? Well, of course, we want to make our applications as inclusive and user-friendly as possible, but it's a very fair question. The vast majority of internet users are still from developed countries, and I don't think it's realistic or fair to say that you should just put in extra effort just to be a nice person without expecting anything in return. But there are practical reasons why you might want to care about the developing world. First of all, technology can avoid path dependence for technologies that never arrived. So an example is WhatsApp. In some places, WhatsApp doesn't have as much competition with SMS because people never used SMS in the first place. And in general, there's going to be less competition because your competitors may be ignoring these areas as well. And I can tell you from direct personal experience that while there are challenges, there are also opportunities that other people won't take because they simply aren't interested in the developing world. And while there are reasons to be pessimistic, there are also reasons to be optimistic. So internet access and quality is growing slowly, but definitely surely. And while the developing world may continue to lag behind, it's also constantly improving. So thank you. That's all I have. I think we should have plenty of time for questions.
Yes. Yes, we have time for questions. So please line up. Who managed to? Okay, thanks.
Can I ask you if it's hard to users like in such countries use just Google Maps, for example, to locate in them? Is it even possible for them?
It depends. So in like major cities, in capital areas, it's doable. It's still like the error rate you'll find is much higher, but you can still look things up by address. So outside of major capital cities, not so much.
Can I ask one more question? Like, what kind of devices actually people use in these areas? Like, usually, I mean, like, let's say, like, more than a half is desktops, and what kind of mobiles do they have?
So I'd say that a lot more people are using cell phones and don't have desktops or laptops. But a lot of people do have laptops. Just because they're accessing the internet via mobile doesn't mean that they don't have laptops. They're just using sort of a mobile router with a SIM card in it that connects to the mobile network to get their internet access instead of a wired connection.
Thanks.
Sure.
How much of the language problem can be solved by using basically non-verbal interfaces, like things that, like pictures that you can manipulate and that sort of thing?
Yeah, so that type of thing can be like really super helpful in a lot of cases. But the issue is that there's only so much you can communicate non-verbally with pictures. Eventually, you have to be able to use language to communicate a certain bandwidth of information to people.
Hi, could you talk a little bit more about how you go about improving an existing site when you're trying to serve an audience on a low bandwidth, or some of the tools that you tend to go about using?
So I could talk more about that. I would guess that a lot of the things that were mentioned in your talk yesterday are similar things that I've used.
So you mentioned that
Last
connectivity
question.
was a major problem, connectivity, in rural areas, and there might be situations where you don't even have an internet connection. So did you ever find that with your team you'd have to implement technologies like service workers to run applications offline as well?
Well, so applications. Well, the short answer is yes. So any sort of offline support that you can support is great, and it's going to be really helpful to people. Often it's only like a very limited amount of offline support that you actually need. And no, I haven't actually used service workers specifically.
Thank you so much, Tom, and big round of applause.